Hello there, this is Video Assignment Chemistry FAD1008. This team consists of 4 members: Muhammad Fakhrul Faiz bin Muhammad Mazran as a leader, Muhammad Azim Harith bin Azman, Muhammad Salihin bin Azizizul, Nur Atirah binti Muhammad Nasir. Topic 7 FAD1008. One of the precursors that causes depletion of ozone layer is believed to be nitrogen monoxide gas, NO, which is produced in internal combustion engine. First Roman. By writing equation for all the process involved, describe the formation of NO in internal combustion engine and how this gas destroys the ozone layer. So, the answer is, this process is called catalytic destruction of ozone. Nitrogen monoxide in stratosphere is caused by the reaction of nitrogen and oxygen at high temperature in jet engines. The reaction equation is nitrogen react with oxygen to form nitrogen monoxide. As we can see, based on the Lewis structure, nitrogen atom in nitrogen monoxide has unpaired electron, which makes it free radicals. A free radical is highly reactive species. The nitrogen monoxide reacts with an ozone molecule, breaking it apart and destroying the ozone. This reaction will form nitrogen dioxide and oxygen molecule. Then, a free oxygen atom reacts with the nitrogen dioxide to form oxygen and nitrogen monoxide. As we can see, nitrogen monoxide is free to repeat the process of destroying more ozone molecules. Because nitrogen monoxide is a catalyst, it reacts at the beginning and is regenerated at the end. If we add both equations earlier, we get this as overall equation for the reaction of how nitrogen monoxide depletes the ozone layers. Oxygen atom reacts with ozone molecules to form oxygen molecules.
Now we will proceed to the question number 2 Roman. From this question we can find that it requires us to find the temperature. So to find the temperature, we need to use the Arrhenius equation, which is K equal to A times exponent power of negative EA over RT, or it can be written as ln K equal to negative EA over R times 1 over T plus ln A. So first of all, we need to find all the values for this equation. So from the question, we know that at 0 degrees Celsius, the half time for the reaction is 30 hours, which is 108,000 seconds, and at 35 degrees Celsius, the half time for the reaction is 30 minutes, which is 1,000 seconds. So this reaction is the first order reaction. So the equation that we will use to find K is T equal to ln 2 over K. So, at 0 degrees Celsius, to find K1, we will insert the value for half time to find the K1. So, the K1 we will get 6.418 times 10 power of negative 6. At 35 degrees Celsius, to find K2, 1,800 seconds equal to ln 2 over K2. So the value for K2 we get 3.851 times 10 power of negative. So we will apply the K1 and a K2 to the Arrhenius equation. But from this Arrhenius equation, we find that we don't know the value of A and activation energy. So what we need to find is activation energy. So to get rid of the ln A, from those equation, we need to assign the first equation 1. Then from the second equation, we will get the equation 2. So we will insert the equation 2 to 1, then we will get ln K1 equal to negative activation energy over R times 1 over T1 plus EA over R times 1 over T2 plus ln K2. Then we derive it as ln K1 over K2 equal to negative EA over R times 1 over T1 minus 1 over T2. So from that equation, we insert all the value, then we will get activation energy is 110,772.25 joule. Now we will look back at the equation. From this equation, we were given the concentration for the NO for the nitrogen monoxides and its rate. So, as this is the first order reaction, we will use the formula negative. The rate of nitrogen monoxide destroys the ozone equal to K3 times N concentration of nitrogen monoxide power of 1, because this is the first order reaction. The sample A, air containing 1.5 times 10 power of 10 molecules per liter, and the rate is 1.5 times 10 power of 8 molecule per liter per minute. Then we change it to the per second, because for the value for K before we use per second. So we get 1.5 times 10 power of 6. Now we will insert the value. So negative 1.5 times 10 power of negative 6. This is negative because this the rate for nitrogen monoxide is the reactant, so it will the rate will be negative, and the concentration we get is 1.5 times 10 power of 10. Then we will get the value for K3 is 1 times 10 power of negative 4 per second. So we will apply to the equation before. We will choose either we will use K3 and either K2 or K1. But for this, I will use K2 equal to negative activation energy over R times 1 over T3 minus 1 over T2. Then we insert all the values we get. Then we will get the value of T3 is 289.28 Kelvin. Then we will change it to the degree Celsius. We get 16.28 degrees Celsius. So the temperature when the sample of air contains 1.5 times 10 power of 10 nitrogen monoxide molecules per liter destroy ozone at rate of 1.5 times 10 power of 8 molecule per liter per minute is 16.28 degrees Celsius. That's all for us. Thank you for watching.